Here we go. When we check out this problem, we're going to begin with the first step. Use two of the three original equations and get a variable to cancel. So you got to look at the x's, look at the y's, look at the z's, and think which one looks easiest to cancel. X's, y's, or z's. Pick one. The y's look pretty easy. Okay, so I'm going to decide to cancel out y's, and which two equations am I going to pick first? The first one and the third one? Okay, so since up there I have it highlighted in yellow, I'm going to highlight the first one and the third one in yellow because it says pick two of the three and get a variable to cancel. And you guys already told me y's is the best way to cancel. Do I have to modify any of them? No, that's why it's great to pick the first one and the third one because they are ready to rock. So what am I going to do? I'm just going to rewrite this one over here. 2x plus y plus z equals 2. And I'm going to rewrite this one right here. That's 2x minus y plus 2z equals 7. And now I can combine them. I didn't even have to modify them. I can combine them. The y's eliminate. I end up with 4x plus 3z, there are no more y's, equals 9. And ladies and gentlemen, this is step one. This right here, this blue equation, is what we're going to call new equation number one. And as you can see, when we read through step one, we picked two of them. We got a variable to cancel, the y's, and we got our new equation number one. It's highlighted in blue because I always write the new equation one in blue. Same thing with the next step. Let's read the next step. It says go back to the original, use the one you have not used, and get the same variable to cancel. Okay, so which one have I not used? The middle one, obviously. I'll just highlight that in red just to stay color coordinated with this red up here. We're using the middle one, and we want this same variable to cancel. I need this positive 2y to disappear. So how am I going to get this 2y to disappear? I could use the top one and multiply it by negative 2, or I could use the bottom equation and just multiply it by 2, right? I'm going to go with the bottom. Okay, so how about this? We're going to use that middle equation, the one we haven't used. I'm just going to rewrite it right here. So it's going to be negative 3x plus 2y plus 3z equals 7. And the reason why I rewrote it is because I know that when I use the bottom one or the top one, I'm going to manipulate the other one that I use in yellow to get that 2y to cancel. So I'm going to use this bottom equation. I'm going to use the bottom equation. I'll, underline it in green. And I'm going to put an arrow over here. But I'm going to put some notes to myself. Multiply by 2. Multiply by 2. And then when I multiply each of those by 2, I will get 2 times 2 is 4 with an x. Negative 1 times 2 is negative 2y. When I go 2 times 2, that's 4. We're talking about z's. And 7 times 2 is 14. Are you with me? Okay. So now we're going to combine those lines. When you look at negative 3 plus 4, that's positive 1x. You don't even need the 1 in front of the x. The y's cancel. And that's great because we needed the same variable to cancel. We canceled out y's on the first one, canceled out y's on the second one. And finally, 3 plus 4 is 7, positive 7. And we are talking about z's equals 7 plus 14 is 21. So this right here is my new equation number 2. New equation number 2. And that was step 2. We used the one we haven't used. We got the same variable to cancel, which produced our new equation number 2. Okay. Step 3, create a new 2x2 system. You're going to take this one, you're going to take this one, and you're going to just write them together, and you will have a new 2x2 system. So let's do exactly that. Here is my new 2x2. It's 4x plus 3z equals 9. It's a 1x plus 7z equals 21. And this is it, my new 2x2 system. I got it from here and from here, just rewrote them. And now I could focus in on that 2x2 and pretend it's what we did last week, because it is. Let's just solve, what do you want to do? Cancel out x's or z's in this case? X's. How could I cancel out x's? -4. Multiply the bottom one by -4. Okay. So the top one, we're just going to leave it exactly the same, all right? Let me rewrite that one since I'm not doing anything to it. 4x plus 3z equals 9. The bottom one we are changing by multiplying by 4, or -4. That'll be a -4x. That'll be a -28z. And that'll be, what is that, -84. Okay, so we have manipulated that bottom one. Now we could combine, eliminate those x's, and we'll get -25z. That's ugly. And when I do 9 take away 84, thank God, it gives me something that's divisible by -25. So let's divide by -25 and solve this. We will get a beautiful answer, z equals 3. Now again, we are solving this new 2x2 system that we created, so I have one answer to my 2x2. I need the other answer, so let's just plug it in either to the top or to the bottom. Which one would you like? Doesn't matter. Top one? Okay. So top one, it reads 4x plus 3z, and you know what? Instead of z, I'm going to put parentheses. Yeah, since we're solving the 2x2 system, we're ignoring everything else, right? We're solving the 2x2 system. We got one answer to the 2x2. You go back to the 2x2, plug it in to find your other answer of the 2x2. So we're plugging in the 3 right in here. And of course, we still have the equals 9. Let's do the math here. We have 4x plus 9 equals 9. And then subtract 9 on both sides. And this is where people freak out for some reason. 4x equals 0. They're like, oh, the 9's canceled. What do I do? It's okay to have 0. 0 is a number, right? It's the same thing as getting the number 3, but it's not 3, it's 0, right? So let's keep solving. How do I get rid of the 4? You divide by 4, divide by 4. If you do this on a calculator, 0 divided by 4 and you hit equal, it'll say 0. So your x equals 0, okay? So once again, let me just go through the steps once again. And check it out, guys. Step 1 was to pick 2 and create new equation number 1 by getting a variable to cancel. We did that. Step 2 was to use the one you have not used and get the same variable to cancel. We did that. Step 3 is to create your new 2x2 system and solve it. We did that. And now step 4, substitute your answers back in the original. I only have 2 answers. We're going to take the x equals 0, the z equals 3, and we're going to plug it back into the original. That way we could find what y is. And you could plug it into any one you want. I'm going to plug it into the top one. The top one is 2x plus y, plus z, which we know z is 3, equals 2. Again, I know x, I know z, that's why I put parentheses. X is 0, z is 3. Do the math. 2 times 0 is 0. 0 plus y plus 3 equals 2. That's really just y plus 3 equals 2. Subtract 3, subtract 3. Y equals -1. So our ordered triple, our answer is 0, -1, 3. And of course, it would be great to triple check that answer of, what was the answer again? 0. Okay, and how would I triple check it? Just plug in 0 right there. And if you want on your paper, just write some notes, like 2 times 0, just put a 0. And then when you plug in -1 into the y, that's 0 plus -1. Now when you plug in 3 for the z, that's just a plus 3. So when you do -1 plus 3, you really will get 2, right? When you do the same for this one, 0 times -3 is 0. -1 times 2 is -2. And then 3 times 3 is 9. So negative 2 plus 9 really is 7. When you plug in 0 right there, it's 0. Negative 1 right there, it's actually positive 1. 3 times 2 is 6. Positive 1 plus 6, it really is 7. We triple checked it. We know that it works. We know that that's the correct answer. When you type it in with no spaces between your terms, and you should get this one correct. Take a look at this one. So on this one, I don't want you to always go to the steps and try to forcefully do the steps. You got to understand why we're using these steps. Like, what's the purpose of picking two equations and getting a variable to cancel, create a new equation 1? What's the purpose of going back to the one you haven't used and get the same variable to cancel to get new equation 2? The purpose of that is to actually create a 2x2 system, because we know how to solve a 2x2 system. Okay, so if you look at this, we have z equals 1. That's an actual answer. So you guys see a z right here, right? You could actually put the 1 right into that z, and you'll now have this equation that has two variables. And if you plug in the z of 1 right there, you'll have another equation that only has the same two variables, x's and y. So you could kind of jump to step 3. Again, the goal is to create a 2x2 system. That's what I'm going to do. And let me show you. I'm simply going to take the z value of 1 and plug it in to here. Okay? So when I plug it into there, my equation up on top will be 2x plus 5y plus 2 times 1 equals 6. And of course, I could clean this up a bit. 2x plus 5y plus 2 equals 6. So let's move that 2 over to the other side. And we will have 2x plus 5y equals 4. Now, ladies and gentlemen, that is an equation that only has two variables, right? It only has two variables. It only has x's and y's. You could call this, if you want, new equation 1, even though we're not going through the actual steps. We produced an equation that only has two variables. And if you look at the middle equation only has two variables as well. And guess what? It's the same exact two variables as that one. So if I have an equation with two variables and I have another equation with the same two variables, technically I'm at step 3. I already have a 2x2 system. So I'm going to take this guy right here, and I'm just going to write it together over here with my new equation number 1, creating a new 2x2 system. So what is my new 2x2 system? It is 2x plus 5y equals 4, and it's 5x minus 7y equals negative 29. So I just need to solve this 2x2 system. What would you like to cancel, x's or y's? X's seem a little easier. How could I cancel out x's? So we know we want 10 up here and a negative 10, or you could have done negative 10 and 10. It's totally up to you. We're going to multiply the whole top one by 5, giving us 10x plus 25y equals 20. The bottom one, we're going to get negative 10x plus 14y equals positive 58. Getting a little nervous with these bigger numbers. The x's cancel. We end up with 39. Gosh, that's horrible. Equals 78. But luckily, when we divide by 39, what happens? Y equals 2. So again, we are solving our 2x2 system. Okay? So we take that y value of 2, plug it back in, either to the top or to the bottom, whichever one you want. I'm going for the top. It reads 2x plus 5y equals 4. Of course, we know y is 2, so let's put the 2 right in there. We really have 2x plus 10 equals 4. Subtract 10. We'll get 2x equaling negative 6. giving us a final answer after we divide by 2 that x equals -3. Yeah? Okay. Now, if we were following the steps, we'd say, oh, let's take these two answers and plug them back in, right? But that's kind of pointless because they gave us that third answer, z. So we already know that our answer is the ordered triple -3, comma, 2, comma, 1. The only thing that you should be worried about is, did you actually use all 3 equations in your system? The answer is yes, right? We use the middle one, we use the 1 to plug it in, we use the top one to actually plug in the 1. So this is your answer, and of course you could triple check it by plugging it in. So if you wanted to, plug in a -3 right there, that's -6. Plug in a 2 right there, that's 10. -6 and 10 is 4. Plug in a 1 right there, 2 times 1 is 2. 4 plus 2 really is 6. Plug in a -3 right there, that's -15. Plug in a 2 right there, it's -14. -15, -15 and -14 is -29. And the z, the only one you plug in is the 1, and definitely 1 equals 1. So we have triple checked it. We know that that's the correct answer. And that one I wanted to go over because it looks weird. They actually gave you an answer. So in reality, they're giving you a 2x2 system.